Welcome to Jeremy's IT Lab. This is a complete course for the CCNP ENCOR, Enterprise Core exam. In this lab, we will configure VTP in this LAN of 4 switches. Note that I'm using the CML unmanaged switch node to represent PCs in this lab. We won't actually use them. I just wanted something to connect the ports of switch 1, 2, 3, and 4 to. And the unmanaged switches don't use up CPU and RAM. So let's look at the lab instructions. At the top there is a note saying, aside from these lab steps, I recommend experimenting to get familiar with VTP's behavior by changing VTP versions and modes, seeing if the switches sync, etc. There are some behavioral differences between the VTP versions. I didn't cover them all in the lecture video, and although I will mention 1 or 2 more details in this video, I'm not going to cover everything there is to know about VTP, so make sure to spend some time learning VTP in the lab. And before step 1, it says to enable VTP event debugging on the switches beforehand. There is no debug VTP command. The command is debug SW-VLAN VTP, and then there are some keywords like events. So I'll go on switch 1 first. Enable debug switch VLAN VTP, and let's check the options. So there are a few options here. For this lab, I'll just use events. Next, I'll do the same on switch 2. Enable debug switch VLAN VTP events. Then switch 3. Enable debug switch VLAN VTP events. And finally, switch 4. Enable debug switch VLAN VTP events. Now let's move on to step 1. Configure VTP domain JITL and VTP version 2 on switch 1, and then check switch 4's status. What are switch 4's domain, version, and revision? So I'll return to switch 1. First, I'll confirm the state of VTP here. Show VTP status. Okay, there is no domain name. Note that the number of VLANs is 7, and the revision number is 2. The default state is 5 and 0, but I've already configured switch 1's G01 and G02 interfaces in VLAN 10 and 20. So switch 1's VTP revision number is 2, although it isn't sending any VTP messages yet. Okay, let's configure VTP. Conf t VTP domain JITL. And we'll get some debug messages about VTP messages being sent and received. And next the version. VTP version 2. Again, switch 1 is going to send some more messages. Now let's go on switch 4 and check its state. First, let's look at these debug messages on switch 4. At the top, you can see summary packet received in null domain state. And below it, summary packet received, domain JITL. And then below that, transitioning from null to JITL domain. This debug command is quite useful to see how VTP is operating on the switches. Okay, let's check the current status. Show VTP status. So switch 4 has joined the JITL domain, and has also started using VTP v2. Let's return to the lab notes for step 2. Configure switch 2 in transparent mode, and change the VTP domain name to JITL, all uppercase letters. Configure VLAN 2 on switch 1. Which switches sync to switch 1, if any? So we'll test if switch 2, as a transparent switch, forwards VTP advertisements in a different domain. And then it says, change switch 2's domain name back to JITL. Does anything change? So let's go on switch 2 to try it out. First, I'll configure it as a transparent switch. Conf t VTP mode transparent. And then change the domain name. VTP domain JITL, all uppercase. Notice it says the domain name has changed, because the VTP domain name is case sensitive. Now let's go to switch 1, and I'll create VLAN 2. The command is VLAN 2, and then to actually create it, I'll exit out of VLAN config mode. Now we're going to get a bunch of debug messages like this. When using debug switch VLAN VTP events, this happens when creating VLANs. I've noticed that it doesn't happen in version 3, however. If you want to avoid this, just turn off the debug before creating a VLAN, and then turn it on again after. Anyway, let's go to switch 2 and check for debug messages. So it says dropping packet received on trunk G00, not in domain JITL, lowercase. So switch 2, a transparent switch, isn't forwarding switch 1's VTP messages because of the domain name mismatch. I'll go on switch 4 to confirm. Let's see if VLAN 2 exists on switch 4. Show VLAN brief. So VLAN 2 doesn't exist. Now let's return switch 2 back to the same domain as the other switches. VTP domain JITL, all lowercase. And to make switch 1 send another VTP advertisement, I'll go on switch 1 and disable G00. Interface G00, shutdown, and then re-enable it. No shutdown. There is a message saying delaying first flood on new trunk, but as you'll see, it then starts sending and receiving VTP messages. Let's see what switch 2's debug output looks like now. Now it says relaying packet received on trunk G00 and G01 in transparent mode. Okay, so if I go on switch 4 now, it should have added VLAN 2. Let's check. Show VLAN brief. Okay, there it is. Let's return to the lab notes for step 3. It says configure VTP version 3 on switch 1, switch 3, and switch 4. Create VLAN 3 on switch 1. Does switch 2 forward the VTP v3 advertisements? So we're testing if a version 2 transparent switch forwards version 3 messages. And then it says to configure version 3 on switch 2 afterward. So I'll go on switch 1 and configure VTP version 3. VTP version 3. And then I'll do the same on switch 3. Conf T, VTP version 3. And finally switch 4. Conf T, VTP version 3. Next I'll go on switch 1 and create VLAN 3 to see if other switches sync to switch 1. VLAN 3. But I am unable to create a VLAN because switch 1 isn't the primary server. Let's change that. Do VTP primary. Now we have to wait a bit, maybe around 10 seconds. Switch 1 is checking the VTP domain and looking for any conflicts. I'll explain what a conflict is later. Okay, now I'll just hit confirm. And switch 1 becomes the primary server. Now I'll make VLAN 3. VLAN 3, exit. To see if switch 2 forwarded the VTP v3 messages, I'll go on switch 4 and see if it learned VLAN 3. Do show VLAN brief. Okay, switch 4 now has VLAN 3, so we can conclude that switch 2 did forward the VTP v3 messages, even though it's using version 2. Finally, I'll enable version 3 on switch 2 also. VTP version 3. Okay, now I'll go back to the lab notes for step 4. It says configure and encrypt VTP password Jeremy's IT lab on switch 4. Create VLAN 4 on switch 1. Does switch 4 add VLAN 4? And after that, copy the encrypted password from switch 4 and configure it on the other switches. Create VLAN 5 on switch 1. Does switch 4 sync its VLAN database? So let's test out VTP authentication. I'll go on switch 4 now. And let's configure the password. VTP password, Jeremy's IT lab, and which option should I use, hidden or secret? The answer is hidden, which will encrypt this password. Now that switch 4 has a VTP password, I'll go on switch 1 and configure VLAN 4. VLAN 4, exit. Before checking switch 4, let's see if switch 3, which doesn't have a password, added VLAN 4. Do show VLAN brief. Yes, it did. So switch 2 forwarded the VTP advertisement from switch 1, and switch 3 added VLAN 4. How about switch 4? Let's check. Do show VLAN brief. Switch 4 hasn't added it. And if you check these debug messages, it says rejecting invalid summary advertisement and dropping the packet. That's because only switch 4 has a password configured. Now let's copy switch 4's password and configure it on the others. I'll use do show VTP password, and the password is displayed in encrypted form. I'll copy it, and then configure it on the other switches, starting with switch 3. Of course, one option is to just configure VTP password Jeremy's IT Lab hidden on switch 3 too, but the secret option allows you to configure the password without using the plain text string, so we'll try it out. VTP password, then I'll paste it here, and then secret. Next, I'll do the same on switch 2. VTP password, paste the password here, and secret. And finally on switch 1. VTP password, paste the encrypted password, and then secret. Okay, let's create VLAN 5 and see if switch 4 learns it, and also VLAN 4, which we created before. VLAN 5, but we get an error message. Because I configured a VTP password on switch 1, it is no longer the VTP primary server. So I'll make it primary again. Do VTP primary. Because I configured a secret password, I have to enter the password. Again, it'll take maybe 10 seconds or so, but after it's done checking for conflicts, I can hit enter to confirm it. And now I'll create VLAN 5. VLAN 5, exit. To finish up step 4, I'll go back to switch 4 and see if it learned VLAN 4 and VLAN 5. Do show VLAN brief. Okay, both VLANs are now in switch 4's VLAN database. Now let's move on to step 5 of the lab instructions. Step 5 says, shut down switch 4 G00 and then make switch 4 a primary VTP server. Then re-enable G00. The line below says to view VTP devices on switch 3 and identify which switch is marked as in conflict with the domain. Before configuring switch 4, I'll use the command on switch 3. The command is do show VTP devices. This command can take a bit of time, maybe 10 seconds or so. As I said in the lecture video, this command only works in VTP-v3. It shows information about the other devices in the domain, although transparent switches won't appear in the output. So notice there is a conf column. This means conflict. Currently everything is fine, no conflicts. As we can see here, switch 1 is the primary server. Okay, let's go back to switch 4 and disable G00. Interface G00, shutdown. Next, I'll make switch 4 a primary server with do VTP primary, and then enter the password. So what we're testing is what will happen with 2 primary servers in the domain. Under normal circumstances, there can only be one, but we'll see what happens when a lone switch that has declared itself primary is connected to the domain. Okay, now that switch 4 is primary, I'll re-enable G00. No shutdown. So now there are 2 primary servers in the domain. Let's go on switch 3 and see what it thinks about the situation. I'll use do show VTP devices. So this time I'm expecting both switch 1 and switch 4 to claim that they are the primary server for the domain. Which one do you think switch 3 will believe? Well, this time in the output, there is a yes in the conflict column for switch 4. So switch 3 recognizes that switch 4 is in conflict with the domain. Notice here, both switch 4 and switch 1 each list a different primary server, their own MAC addresses. Now let's return to the lab notes and see step 6. It says to create VLAN 6 on switch 1 and VLAN 7 on switch 4. Then we'll see which one switch 3 syncs to. And after that, make switch 3 the primary server and see if both switch 1 and switch 4 become secondary. Okay, I'll go on switch 1 first. VLAN 6, exit. And next, switch 4 to make VLAN 7. VLAN 7, exit. Now let's go on switch 3 and see which VLAN it added, 6 or 7, or possibly both. Do show VLAN brief. So switch 3 added VLAN 6. Switch 3 is not accepting switch 4's advertisements. As I mentioned in the lecture video, VTP version 3 really solves the problems with version 1 and version 2. In those versions, there is the worry of a switch being connected to the LAN and overwriting VLANs on other switches, but not in version 3. Okay, now I'll make switch 3 primary with do VTP primary, and enter the password. So let's see if both switch 1 and switch 4 accept switch 3 as the primary server. This time, because there is a conflicting device, instead of saying no conflicting devices found, it shows switch 4 here. I'll hit enter to confirm. Let's check with do show VTP status. Okay, switch 3 is primary. Next, I'll check on switch 1. Do show VTP status. Okay, switch 1 just says server, meaning it's a secondary server. And finally, switch 4. Do show VTP status. Switch 4 also says server, so both switch 1 and switch 4 have now accepted switch 3 as the primary server. No more conflict. Now let's go back to the lab notes and look at steps 7 and 8 together. They are both about VTP pruning. Step 7 says to activate VTP pruning on one of the switches, and check if the other switches activate it too. In step 8, we are to ensure that all switches have pruning enabled, and check where pruning has occurred. First of all, I'll go on switch 3, and verify that all VLANs are allowed on its trunks. Do show interfaces trunk. So all VLANs are allowed. VLANs 1 to 6, 10, and 20 are allowed and active in the domain. Those are the VLANs that exist on switch 3. And then none of them are pruned or blocked by spanning tree. So I'll enable pruning here. VTP pruning. And let's check the trunks again. Do show interfaces trunk. No changes. VTP pruning requires other switches to have it enabled. In the lecture video, I said that you only need to enable it on one switch, but that's another minor difference between version 3 and versions 1 and 2. In version 3, you actually need to enable it on all switches. There are lots of small behavioral differences between the versions like that, so I recommend spending some time experimenting in the lab and also reading Cisco's documentation on VTP. I'll go on switch 4 next. Just to confirm, I'll use do show VTP status. As you can see near the top, VTP pruning mode is disabled, so I'll enable it. VTP pruning. Then I'll enable it on switch 2. VTP pruning. As this message states, only a VTP server or client can configure pruning. It doesn't work in transparent mode. So I'll use VTP mode server to make it a server, and then VTP pruning. Okay, last is switch 1. VTP pruning. Finally, I'll go on switch 3 to confirm the results of pruning. Do show interfaces trunk. So the allowed VLANs don't change. VTP pruning doesn't actually change the allowed VLANs, like when doing manual pruning. The only section of this output that should change is the final section. On G00, it only forwards traffic in VLANs 1 and 20. 1 because VLAN 1 can't be pruned, and 20 because switch 4 has a host in VLAN 20 connected. On G01, it forwards traffic in VLANs 1, 10, and 20. The VLANs we created in this lab, VLANs 2 to 6, have all been pruned, and actually all of the switches will prune them. There aren't any hosts in those VLANs in the network. Okay, in this lab we explored some aspects of VTP, mostly reviewing what was covered in the lecture video, but also introducing a few new points. Although the information in these two videos is probably enough for ENCOR, I recommend checking out this configuration guide from Cisco. Just do a Google search for VLAN Configuration Guide, Catalyst 9300 or something like that. This has all the details you'll need, including ones I didn't cover in these videos. Okay, that's all for this video. Thanks for watching. Before finishing this video, let me thank my JCNP level channel members. To become a member, please click the Join button under the video. Thanks to Yonatan Makara, Velva Jacob, Funny Dart, Nasir Chowdhury, Devin Suku, Gustavo B.R., Marcel Lord, Pavel M., Mr. Erlison, Dragos Hirnea, Zakib Shah, Mayor Salman, Mazen Anderson, Vitaus194, Gina Lindley, Mark Jackson, Bold1C1U, Michael Carroll, Gerald Guillaume, Gabriel Braga, Hector Hernandez, Mara Tuba, Roji Kuriakos, Arpad Konives, 5 Feet, Owad, Daniel Brown, Tricky Mickey 123456, Scott Thompson, Jose Alvarez, Hussein Yavuz, Samuel Tavares, Roger Bratseth, Mustafa Ersoy, Nasser Zahar, Brian Grant, Kyle, Georgi Gemejev, Arlen Plagaria, Dear Diso, Adelson Pereira, Farad69, Lucian Stoichitoyu, Madmark 50484, Sean Powell, Alexandru Stratan, Hiago Bicalho, Abdo Zizo, Piotr Kaimov, DMJ2, Kurt Nell, Preeti Dongave, Abubakar Berry, Omid Farakesh, Steve Cox, Jasper Yim, Wilmer Romero, Enigma G, Laurent Lam, Emmanuel Nupsido, King Doka, Pedro Hartman, Ivano Capuano, Jefferson Steelflex, Sinan Sarisinar, Karamjit Singh, Alejandra Okana, Burrell Campbell, and Abhishek Sahu. Sorry if I pronounced your name incorrectly, but thank you so much for your support. Thanks to you and my other supporters, I am able to make these videos and release them for free on YouTube, so I really appreciate the support. Another great way to support the channel is to like the video, leave a comment, subscribe, and most importantly, share this video with others. So if this video was helpful, I'd appreciate it if you did any of those. Thanks for watching.